Right. So first thing I wanted to basically was throw it open to the room. We've had the Hyperlaunch talk this morning. We've talked about the stuff on the way here with Dom B last year and Dom Zerless, available and presented a couple of times. Basically, if there's interest in using this, it would be nice to know, so we can make sure we are covering requirements for whatever you want to do with Hyperlaunch. I know there's a few people from the working group here in our room. If anybody wants to speak up, and we'll add your use case to our list.
So the one I have that I can see on x86 too, and in past hallway conversation at physical conferences, people ask me about, and I think you already have this in mind, so you covered it, I think, briefly during the talk, is fast unikernel boots. Like in embedded, they wouldn't call them unikernels, they would call them bare metal applications. They're basically unikernels.
Yeah.
And they want them to be up as quickly as possible, really as quickly as possible. And I think you're already keeping that in mind. So yeah,
definitely. So one of the things that we'll really want to avoid with providing this boot domain option, basically this domain that will you can configure the system to run this before any of your other domains start. You don't have to do that, right? If you want to go straight into parallel boot of a fleet of VMs, you can do that, but you may need the boot domain in order to do some initial sequencing, in particular things like enabling use of XenStore. So your PV drivers may need to be done by a little bit of logic in a domain that runs first. So each of your subsequent domains know where XenStore is and where your driver backends, if you need some entries in XenStore first. So we're providing this boot domain capability, but we really don't want the boot domain to turn into DOM0, where people basically stuff more and more functionality into that same domain. What we'd really like to go ahead.
I was just going to say, yeah, that the boot domain, one of the things to realize about it is that in the design, when the way the system is supposed to the hypervisor is supposed to finish the system is that it waits for the boot domain to exit, and then it goes into basically what we call the finalization phase, where it finishes bringing everything up. It'll unpause any domains that the boot domain didn't unpause. The boot domain itself, it basically functions like init code, so it will be wiped from memory. The domain will be gone, and you'll be into your target system at that point.
Right. So it creates the space for using unikernel or whatever other term you want, but basically small, single-purpose, short-lived domains for things that you might want as platform services. So I'm interested in the Cubes OS use of the Mirage firewall VM. Seems like something that whether we use that particular implementation or something else based on Unicraft.
I think I'll take this opportunity maybe to spend just 2 minutes just to explain the difference between unikernels and bare metal applications, because I think technically they're very similar, but in practice the philosophy is different. And I don't know if this is only Xilinx or there are other vendors. So that, maybe what I'm saying is only related to Xilinx platforms, but I don't know. So the difference is a bare metal application will never be a service. You see, so the bare metal application is really a tiny driver for a hardware block. That's what it is. Nothing else. Nothing more. So there is a hardware block you want to control. Typically, and this is where it gets to Xalium specific, is because it's in programmable logic. So there is no existing driver for it because you wrote the programmable logic block. You also need to write the driver. You are a hardware guy. The easiest thing for you to do is to write low-level assembly code or a trivial C driver in kernel space. So although technically it becomes basically a unikernel, in practice, this is a single driver written by a hardware-oriented person that would not, so it's not something providing a service such as a firewall, right? Does it make sense?
It does. Yeah.
Doesn't a driver provide a service? I mean, what does it mean to be a driver that doesn't provide a service?
It's not providing a service to other software. It's only in function of the hardware capability itself.
Okay.
Moreover, it's so true that typically they don't need any PV drivers. Why? Because they don't communicate with any other software except for the hardware block.
They just run out. Okay.
Right? So they only need access to a certain MMIO region and an interrupt or two, and that's usually the end of it.
Okay, so when you say driver, maybe it's a bit more like a I mean, it's driver in the sense that it drives the hardware, but it doesn't. It's not like a Linux kernel driver, which is like kind of offers a service. It just controls the hardware and that's it. Okay. Is that what I mean when you say? Okay.
Yeah. It's
sort of a driver/controller in one, maybe.
I don't know how you define driver, but it's something that talks to a hardware block and doesn't really talk to anybody else.
Right.
Yeah.
Okay. So, Stefano, we've had previous discussions where you've got some other interesting use cases for what's currently DOM zeroless. One of the things about, if we're looking at encouraging the use of small single-purpose domains, is the need to schedule these things. It's kind of, we've been looking at, in the domain roles work, we're looking at, the set of permissions and privileges that the different components of the system will want or need. And a Flask is quite handy because it gives us the ability to really customize it in a very granular way. But with scheduling is kind of this whole separate thing that may need.
Right. This is a very good. So yeah, what we discussed, which is an interesting kind of worms, is good for the design session maybe, is that typically these guys, and again, maybe my vision is skewed towards the people that use Xalium ports, right? So I don't know if it's how widespread this is, but the people I'm seeing that care about these bare metal applications, they only have a few of them, and they typically really care about latency. The reason is obvious, because the drive, well, let's call it driver, okay? The hardware controller typically has to respond to something done in hardware within a very limited amount of time, right? So latency is typically very important for these bare metal applications. So to the point that latency is way more important than anything else, right? So if you lose latency, it's like total failure. Disaster happens, right? So it's more important for these guys than security, safety, than anything. Like top priority number one is not to lose the deadlines, right? So if you obviously bring a scheduler in the mix, it makes it a lot harder. That's why not doing any scheduling is typically easier. And then there is and that's not enough, right? Even doing no scheduling is still not enough. You need to do cache partitioning and the cache coloring work and so on. And sometimes even cache partitioning is not enough. So in one recent interaction, there were two domains. This is also an interesting inversion of priorities that you guys will love to hear. So I had two domains, a DOM0 domain, Linux, and a DOM-U, that's the bare metal application. Nothing more, nothing less, no scheduling. So to make sure the deadlines were not broken, like they were always met, I had the DOM-U pause DOM0 during the critical execution. This is an interesting inversion of priority because really DOM0 is supposed to pause the DOM-U. But here, DOM0 is creating the DOMU just because it's Linux. So I don't remember if it was DOM0 was used or not. The point is that DOMU is the most critical thing on the entire system, and you cannot lose deadlines, right? Anything, DOM0 could die, and as long as the DOMU doesn't miss deadlines, it's not a disaster, you see. So, yeah, that's to tell you. And that's, I guess, what you're doing. This helps because you could actually specify privileges that are that match the reality rather than having DOMU post DOM0.
Definitely interesting. So I think Connor is going to be giving a presentation on moving scheduling out of Zen into DOM0. There's also the Chromium architecture. Daniel, in your hat architecture, isn't there the concept of protection domains? I'm interested in this, DOMU actually having the fundamental important workload that has to be executed, but not necessarily being what we think of as the control domain, doesn't have the same set of permissions.
Sorry, I'm not. Where are you trying to get with this line of thinking?
So Stefan has got this use case where DOM-U ends up pausing DOM0 in order for DOM-U to be able to meet its deadlines.
Right.
How does that fit with? So, Stefan, you must have had to change the permission model to give DOM-U the capability to do that.
So what I end up doing is I provided basically 2 hypercodes so that the DOM-U could pause and unpause DOM0. So it was ad hoc, with an ad hoc, basically tailored solution. This is not, nothing generic. I've actually been thinking how I could make it generic, but it's not easy, right? Because there is a pause and unpause vCPU, but this is not what you want. You want to unpause everything else, right? You want to unpause everything else but yourself. So it's a bit difficult, right? I wouldn't know how to make it a generic solution. So it's one of the things that takes 5 lines of code or 10 lines of code if you write a hack, and 10 months if you try to do it properly. So it's really difficult to generalize.
It's because you're not able to express to the Zen scheduler exactly the behavior that you really want.
Well, I mean, there are things to say. So you want to do all the you want to just, you want to cycle through domains and then cycle through each vCPU of each domain and just pause it if it's not you. Is that right? Or
so basically there is a critical section, right? The typically in these cases there is a deadline and a critical section, and when an interrupt or a sort of event occurs, you have to do something within a very, very limited amount of time.
Yeah.
And if you cannot do that, the whole thing failed. You might as well go home. All right. So basically what you want is during the critical section, pause everything else, because the critical section is usually very small anyway. It's probably smaller than actually, I can tell you, it's way smaller than a slot of the title of the scheduler. So you want to make sure everything else is paused, right? So that you are getting the whole bandwidth available, not just the CPU, but also DDR, everything, right? No interruption. You don't want to screw up those, 15 microseconds, right? So you need
part of the question is, I think, how long does it take to pause all the other VMs on the system, right? So the main thing I'd be worried about is if there's you can have a for each domain, and then within each that for each vCPU, and just pause them, but then that involves sending interrupts and waiting for the thing to finish and that kind of stuff. But
yeah, and I solved that problem with another hack, right? And this is again close to the to the 10 lines of code, but 10 months of development to do it properly upstream in upstream. So I had my event that is triggering. I knew which event is starting the critical section. So I made that event the trigger for pausing to 0.
I mean, just offhand, it's just, to me, it sounds like what you need is a scheduler that is aware of these critical interrupts, that when it gets it, it understands that means that domain has to have exclusivity over the system, and can take care of ensuring that you get scheduled exclusivity over the system.
So I see Demi wrote SCL4 can do this with mixed criticality scheduling work. So Demi is not the first one to tell me that in other domains in the past, they use this technique that when the critical section start, everything will get paused.
Yes.
In other industries, decades ago, this technique was already employed. So I reinvented the wheel again. Obviously.
So I guess actually you don't actually need to pause the other domains. You just need to make sure that the other CPUs stop doing stuff, right?
Yeah, you just need to.
Right. So what I did, I actually just left things in. I'm not even pausing the vCPU. I actually left. I busy loop things in.
Well, in a sense, I think that's the right thing to do. So, yeah, I mean, it's similar. It's similar to the core scheduling, except you just make sure that your other that your sibling cores that your sibling cores switch to not doing anything. But
yeah, there's if you go dig, there's lots of academic papers and so forth looking at how to deal with these problems. So, and that's what you see implemented in these things like SEL4 and some of the real hard critical kernels that are out there. Integrity.
Does this come up in the functional safety discussions? No, there's the special interest group.
Not yet.
Okay.
Yeah, so it's a great discussion. How does Hyperlaunch help you?
Well, I was thinking that first of all, the DOMU should not be started from DOM0, right? There are only 2 domains. There is no point in having DOM0 Excel create, right? So especially because there was no PV drivers at all, right? So first of all, it makes sense to use. I mean, if this is not DOM0 list, I don't know what is, right? This is basically as DOM0 written all over it. There is no PV drivers, only 2 domains. It's really like the perfect use case for it. Okay, that's first observation. Second observation, if we had more detailed XSM policies or things like that, then DOM0 could actually be not DOM0. That will be the next step, right? Because if you DOM0 doesn't need to create any other VMs, then DOM0 can also be not DOM0, right? It can be another DOMU. So then you have DOM0less with 2 DOMUs. And then the final step is, if we want, and this is where I had no idea how to implement properly the DOMU is stopping the other DOMU. But that sounds like an XSM policy to me. Sounds like a capability, something expressed through Hyperlaunch. Something to say, this DOMU, like if we had a capability to say, this domain can pause everybody else. But I agree with George that maybe it's better actually to have a special pause, right? This is not just any vCPU pause. This is like a super critical sleep instead of pausing the vCPU thing, right? So, but if we had a capability that advertise that ability, then you will give that to the bare metal.
So there, you could, I don't like it, but you could, so the roles work that I did to help so we could start doing some of these more advanced scenarios with Hyperlaunch, you could, in theory, hijack that and create it and specify a real-time role and use that in the scheduler, build a scheduler, a role-based scheduler that could then understand that role when it gets certain interrupts, and you could potentially label interrupts. See, that's where I'm not liking it. I mean, there's a path there. The other one is Flask would be another way to do it. We could actually use a policy-based scheduler that use Flask to do it, but Flask gives you that fine grain, but there's overhead for running the security engine for the Flask. So, right. I mean, we can look to see how we can balance that, but there's options there we could look at. And obviously Hyperlaunch would be engaged in the making sure that the domains are created with the right labels on them, or the right roles assigned to them, or however we achieve this capability.
So the ARINC 653 scheduler was mentioned in the chat. Artem, have you got experience with using that for particular configurations?
No, we didn't use. We are sticking in our research. We use RTDS, and we also used it when we played a little bit with full preemption for Zen. I think you've seen it, but not with ARINC. It's very how to say, special for its own niche. So for me, it's we're really interested in RTDS, and I think we discussed it sometime, and I really wanted to explore options like using Slack when you're budgeting some time for domain. There's Slack, and you can use for the ones that with like best effort priorities, and so RTDS seemed to us like the best option for future extensions and development. But we didn't. ARINC is like very much specific for a particular goal, and it does what it's supposed to do.
Okay.
Are you using it?
No. No. Really, with Hyperlaunch work this far, it's been focused on enabling running without a DOM zero. That's what the prototype was about.
So, Chris, maybe I can tell you a little bit of about our scenarios, and those are obviously on ARM. And we also distinguish between hardware domains and controlling domain. We are using DOM zero as a controlling domain only to act as a kind of initially it boots, but also acts as a watchdog. So if everything dies, it's able to recreate. And since we're using device, we don't have ACPI, we just split hardware between different domains. So one domain can talk directly to some piece of hardware, another domain can talk directly to another piece of hardware. So they all are like in a sense are hardware domains, right? And since hardware drivers are prone to be faulty and suppliers are having all kinds of issues with those, we split those into different domains. And like when we need, we can try and restart the GPU from DOM zero. And since, as it was mentioned several times, DOM zero on the path of safety certifications and maybe other certifications, we are now working to put Zephyr as a DOM zero. So we have like event channel. It's a very draft implementation. We're still working on it. It's not far from being ready. But what we want to have is like some small RTOS acting as like a starter in DOM zero. And then we also don't put kernels in DOM zero. We put a bootloader, so that bootloader spits out a domain. DOM zero spits out a domain, gives a generic bootloader, which is like common for all other domains. And then other domains are having their own like file systems and everything, and they know which kernel to use. So DOM zero becomes like a very small and very generic and not depending on other domains kernels and so on. So it's like pure control functions. Maybe with some hardware drivers, if we had a case when we wanted to put CAN bus or other things which are basically a control interface. So from outside we can get some commands or something. Yeah. But not sharing those, not virtualizing those.
I guess I'm interested if there's a diagram of what your system looks like.
Yeah, it's just an examples of. Yeah, I can send it to you. I can send maybe on a mailing list or attach somewhere. I don't know how to attach it here. I'll send it to you, Chris.
Okay, thanks. Okay. All right, so I feel like I've steered everybody towards scheduler and unikernel type topics. That was my interest for this session. But Daniel, did you want to solicit anything in particular? You're muted, by the way.
Yeah. I was trying to get my cursor over to it. Sorry. Let's see here. In terms of input, I mean, the design doc is out there. It is massive. I think what we want to make sure is that we're good on this idea of the boot domain, the understanding of how these handoffs are going, the roles work, the subtasks to do the roles work, and getting that integrated in so we can be able to do these disaggregated boots, regardless of what, and, from my perspective, especially with the roles work, I think we need to start getting, some of that work and as we highlighted in the keynote this morning, right, we've come up with these new definitions of roles within the Zen system that really kind of breaks us up, and need to get away from this concept of is control domain is hardware domain, right, and really start thinking about what role we're asking a domain to do on the function as, because I've seen it just today, which is why it came up, which is people have different views of what a control domain is and what a hardware domain is. And we need to get to a common language that a way when somebody says, oh, it's this role, then everybody understands what you're talking about. And then there doesn't, we're not having to deal with all this misconceptions that happen that may not always get aired, that there is that misconception. So yeah, my biggest thing, review the design doc, get us some feedback. I will be adding a design doc for the roles work as well eventually. I have a draft form of it. I just want to flesh it out further. And hopefully we can get all that adopted. So, all right. Is there anything else, Christopher, we should go over? We still got 15 more minutes, so if I'm correct. I think we got I think design sessions for 45 minutes.
Yeah, I think we got 15 minutes left to use.
Yeah, we got 15 minutes. So, I mean, questions, please.
I have questions. It's related to DOM zeroless on Hyperlaunch. Is the plan to completely remove DOM zeroless? How are you planning to keep the two together in the code?
The intention is to integrate, basically, so there'll be no boundary between the two of them. Everything that you're doing with DOM zeroless should continue to work. If there's code movement from ARM to common, if it's not already there, we'll have to look at that.
Yeah.
Go ahead.
So yeah, I mean, in terms of the code, right, that's where Christopher's going, right? The code's going to be, we'll leverage what's there for DOM zeroless, and because, right, DOM zeroless has this idea of constructing domains from the hypervisor. We're going to continue that code. That'll really become common code, and it'll be used by both ARM and x86. I think one of the biggest differences that will have to be a migration, I guess you could say, of moving away from DOM zeroless to Hyperlaunch. And I don't know what that migration period will be. And I think there shouldn't be a reason why we couldn't support the two of them is in terms of how the configuration gets in there, right? So for Hyperlaunch, we went with a much more broader device tree definition, and we're trying to ensure that we're all aligned with system device tree and all that. And DOM zeroless today has a specific device tree configuration they have, which is, I would say it's totally different, but it is different. And so So for some period of time, yeah, the parser for the DOM zero-less device tree is going to have to coexist with the Hyperlaunch one until I don't know where the consensus will be. Go ahead,
Let's try to
Stefan.
make so I already had this problem for another reason. So as you know, the system device tree effort is basically very similar to Hyperlaunch and DOM zero-less, right? And is defining this concept of domains that can be VMs for Xen, or could be bare metal things running on a coprocessor and so on, right? So one of the things that I'm looking to do the next few months is to finish cleaning up the definition of the domains in system device tree to cover VMs properly. It was always discussed, but the bare metal ones were the first target. This is to say that we should definitely align very well Hyperlaunch with the system device tree domain, because I already had a migration in mind from DOM zero-less to system device tree, so we don't want to do two migrations. One is painful enough. And originally, I was thinking, I know this doesn't help you, okay, but just to throw it out there, I was thinking of so system device tree comes with this tool called Lopper, and Lopper is meant to from a single system device tree to be able to generate multiple device trees, one for each domain. And for VMs is less interesting, right? Because device tree for VMs can be very different from the one on the host, but this is a lot more interesting for bare metal domains, where you have a domain like FreeRTOS running on a Cortex-R. Exactly that one. Yeah, thanks, Christopher. So when you have FreeRTOS running on the Cortex-R, the device tree is going to be very, very similar to the one of Linux running on the Cortex-A, let's say, right? With a few differences, but very similar. Anyway, so Lopper is there, it exists, and can generate multiple traditional device trees from one single system device tree with multiple domains. So one thing that Lopper supports is plugins. So it has a pluggable architecture, so you can write a small Python extension and basically do any kind of manipulation you want. So I was thinking to write a Lopper plugin so that it will convert the system device tree format into DOM zero-less format, so that at least initially we wouldn't have to change Xen parsing. But obviously, changing the Xen parsing, I think eventually would be better, right? I mean, this is more like for filling the gap.
Right. So one of the things you're looking at getting from system device tree to the device tree that's passed at boot. One of the things when you shared the Lopper stuff with us for system device tree is that you could, with Hyperlaunch, boot with the system device tree and pass the system device tree into your boot domain where you have Lopper running, and Lopper could actually generate your domain device trees, the device trees for your guest domains that you want to start up. That's one of the use cases.
So that would be very cool. Let me tell you. So the fact that the system device tree, so far we always use it at build times on. But it was always an idea that it could be used at runtime too, right? Because if somebody knows about multiple domains, and Xen is a limited example of that. There are even better examples like a firmware running on a board overseeing the power management of the old board. That guy will have to see definitely all the domains running, right? Because it has to do. Anyway, so there are interesting examples of system device tree running at runtime as a spec. But this is the first time I hear mentioned Lopper, because Lopper being in Python is more interesting at build time. I thought that if we were going to have some kind of tool like that at runtime, we would have to rewrite it in C or something tiny. But I haven't thought about that.
Yeah, well, actually, if you really wanted to do something like that, you could, right? The unikernel or Unicraft guys, right? They have their micro Python Unicraft kernel that allows you to embed scripts as a unikernel. So you could literally do a Unicraft unikernel Python domain that has Lopper and some logic around it, and run that as your boot domain to basically take the system device tree, which was used to construct all the domains, to then do the device tree generation And from a security standpoint, that's nice because now the hypervisor is not having to be in the business of generating device tree for domains. It's now pushed into an initialization domain, the boot domain, that can quickly run through it, generate it, push it through the mechanisms that we've been discussing about for transferring data from the boot domain to the running domains. And you could then have it all as runtime in a clean, safe architecture. Using Python.
That being quite interesting for CI looping as well, right?
Yeah. That's so. And I guess that's another thing to take these things and let your mind run free. I mean, the things you can do with this is, there's lots of scenarios that we haven't come up with that I'm sure other people might think about and say, well, could I do this? And the answer is probably yes. And if you come to us, we can help you walk through them, or if you maybe even can fully craft it yourself. So, and we can actually make, if it imparts some requirements we might need to have inside of Hyperlaunch, we can ensure that they're taken care of.
So I have a couple of comments. So in your presentation, you said that you were managing the scope, because it could become quite big. So
yes.
maybe you could talk about some of the things you have left out of scope. Also potentially, areas where funding would help, areas where other contributors would help. The other thing is, I don't think you've mentioned too much the details of how Trench Boot is connected to this, or just launch integrity in general. And both in the US and the EU, there is a top-down effort for supply chain security powered by ransomware and Bitcoin. So there's buckets of money being sort of thrown around to get more integrity in the software stack. And they're pushing what do you call it, secure bill of materials, right? Which we saw in the October event. So basically, if you have a secure bill of materials and your Hyperlaunch system with Trench Boot can prove that the thing running matches the thing, this manifests, people might want to pay money for that and then help drive your roadmap.
Yeah. So I'll address the Trench Boot first real quick, and then I'll let Christopher answer the scoping. So correct. When this was original, the whole idea of this spawned out of the same thoughts that created Trench Boot. It was proposed, like we talked about in the keynote. The original proposal we put out was back in May of 2018, I think it was, May or June. And that was driven by, we were thinking about how did we want to use Trench Boot to, in a Zen launch system where we had the security properties we were seeking, but without blowing up in terms of size and code and responsibility into the hypervisor. So that's what drove it. So that's where, and if you saw the Trench Boot developer forum, I talked about that there's the standard pattern that we're trying to follow with Trench Boot, which is you launch into a kernel, which then launches into an integrity measurement system, a security engine. So the way that maps into Zen is that we do a DRTM launch into Zen. Zen then starts a boot domain, which is what is our security engine that runs in a restricted environment that's protected to take measurements of the system and provide you a testable information, a testable evidence to what's in your system to the degree that's possible. So, but at the same time, we knew that everybody didn't want to do it. So we didn't want to just have a capability specifically focused on that. So and there had been already discussions about a bootstrap domain that we linked to when Daniel DeGraff did the original hardware domain. He posted an example boot domain capability. So we've basically been building on all of this as the foundation to build to motivate how this was laid out. And so now I'll let Christopher, we got only a couple minutes left. I'll let Christopher talk about scoping.
So, sorry, just make sure what would you like me to talk about?
So remember how we talked about how we're constantly trying to deal with scope creep, keep the project focused.
Yeah,
because we pull on a thread and it just keeps unraveling.
Right. So the question was very specific, right? Are there things you have, you wanted to do but you've postponed, or are there tasks where you need external people to help, or external funding sources that would allow those features to be addressed?
PCI pass-through is the big one that we've kind of kicked slightly out of scope for our initial work, right? It is really important, and it's going to be highly complementary to Hyperlaunch to be able to do pass-through of PCI devices right from start of all your initial set of virtual machines. So they don't start off assigned to a DOM0. It's going to be a significant improvement, but PCI pass-through is seriously complex, which is why it's had its own talk. In fact, it wasn't just PCI pass-through; it was PCI pass-through scoped down to ARM platforms. Right? It was an entire talk here, and there's a bunch of work involved there. So that's one. An additional one that we've sort of deferred on is the recovery domain. It's mentioned in the design document. It's the basically the ability to have a VM built, configured, and when some failure scenario is detected during host boot, say one of your domains that is critical to the functioning of the system doesn't start or errors or terminates sooner than it ought to, you want the ability to have this recovery domain so that you can put rescue logic in there to enable recovery of a system or remote management of a system or whatever it is you want to do. There's quite a bit of complexity involved in the design of that. Detection of failure conditions and appropriate handling and reclaiming of resources, whatever. That's an interesting topic all of its own. So we've punted on that one for the time being.
Yeah. So for the roles work, right? From the roles work, I'd done the minimum we needed to support Hyperlaunch, but that definitely, if you kept following that could go much further, right? We can really get the XSM framework cleaned up. We can get Flask in a much better position. We can look at more advanced roles that might make sense to create those roles and scope them out. Going through and reevaluating all the XSM hooks in terms of roles and everything, and just getting all of the security framework in a better state. There's,
in particular, Daniel, on that one, with what people are going to use the boot domain for, is to determine the set of permissions that we have for boot domain roles, and that's not part of the work we've done so far, right? At the moment, we've just been breaking down the existing structure of DOM0, but the boot domain is sort of introducing a new thing, and you don't want to give it everything that the control domain has. That's
I think we got like a minute left, if that. So
no, I think your time is up, guys. So
okay, all right.
Thank you.
Thank you.